2, 3, 4, 5, 6, 7, 8, 9 are common between the two sets. So that constitutes the intersection. It turns out in this case that the intersection coincides with one of the sets. When intersection coincides with one of the sets, then it means that that set is a subset of the other one. Otherwise, the intersection will not coincide. So intersection does not always coincide. For instance, if there are other numbers here that are not here, then so there will be an intersection and there will still be some things that are here and not here. So that is, so this is what we mean by intersection. The intersection of two sets is a set containing elements that are common to both. So the intersection itself is also a set. It is a set. If one of the sets is the same set as the intersection between the two sets, then we have a containment as we have just shown. So this alphanumeric English and numeric Arab is equal to Arab. So when you do the intersection of these two, you get one of them. Then that means that this Arabic numeral set is a subset of this. If there are no common elements, then the sets are disjoint. So an empty, the intersection is an empty set. The sets are disjoint. So a set is said to be disjoint when the intersection contains no elements. And so when the intersection between the two sets contains no elements, then the intersection is an empty set. Then the sets are disjoint. So the set alpha English and numeric Arab, that is the alphabetic English letters and numerals, the Arabic numerals, there's nothing, they don't have anything in common. So so the intersection between them is the empty set. Now, we will just take a look at some important results. For instance, we have just explained that if the intersection of A and B is A, then all elements present in A are present in this intersection. Then it means that the elements of A are also in B without the element. Then A is a subset of B. If the intersection of A and B is 0, is the empty set, where we use this symbol, an O with a slash, to denote the empty set. That is the mathematical symbol for the empty set. In which case there are no elements common to both. The sets are disjoint. They are disjoint. And then this converse is also true. If sets are disjoint, then there are no common elements. The intersection is an empty set. This can be taken as a definition of the relationship between this, the relationship, the joint between two sets. So we have explained that. So the intersection, this is just a repeat of what we have just said. So let me just move on to the next thing. So furthermore, we can write this, when we say numeric Arab is a subset of alphanumeric, when something is a subset, so we can say, we use this sign. This sign is the subset sign. This sign is implication, it implies. This is subset sign. Numeric Arab does not have any element in common with alpha eng. So this and this do not have any element. So their intersection is the empty set. Intersection between this and this is empty set. We can also talk of union. Given two sets S and T, we call one set S, we call the other one T. Their union is a set containing all the elements that are in either set. So all the elements that have. An element that is either in S or T is a member of the union. So all that a member needs to satisfy to be in the union, it just belongs to any of those sets. So it contains all their elements because any element in one of them is a member of the union. Note that the elements in the two sets are not necessarily all distinct. So that is, the two sets themselves may have an intersection. Every element in any set is distinct. But if you have two sets, they may share elements in common. We will see an example shortly. It is therefore possible that the number of elements in the union is less than the sum of the number of elements in two sets. If this statement is difficult for you to understand, just be patient. We will, in the next two slides, we will give a concrete example to explain it. The union of a set with its subset is no different from the set itself. So here, the number of elements in the union is numerical Arab. What we are saying is that if you take this one and you take the union with this, the union of a contained set is still the same as the containing set. The union of these three sets is still alphanumeric edge, since this alphanumeric edge contains all of this. So when a set is contained, its union does not change anything. Its union is still the containing set, when it's the union with the containing set. So the set alphanumeric edge contains numeric Arab. Therefore, their union is the containing set alphanumeric edge, like we have said here. Similarly, alphanumeric edge, which is this one, contains alpha edge, which is this one. Therefore, their union is alphanumeric edge. So the union of this and this is this. The union of this and this is this. In fact, the union of the three of them is still this, because since this contains both of them. In general, the number of elements in the union is less than or equal to the number of elements in the derivative sets if you count them one by one. Yeah, we will see why this is so. Okay, again in the next two slides, it will be clear why this is so. The equality taking place only when the sets are disjoint, so that the intersection is the empty set. If we write the number of elements in S as ns, then ns plus nt will always be greater than n of the number of elements in their union. Is greater than or equal to, and the equality only happens when the intersection is the empty set. The actual equation is this: the number of elements in a set plus the number of elements in the other set is equal to the number of elements in the union plus the number of elements in the intersection. This formula is the fundamental formula in set theory. First of all, it's not a matter of memorizing. It is such a self-evident thing that you should be able to see it every time. So it's not something meant for memorizing. We are going to demonstrate it rather than give it to you to memorize. Look at it. If you have set S and T, the number of elements in S plus the number of elements in T is equal to the number of elements in the union plus the number of elements in the intersection. Or the number of elements in the intersection plus the number of elements in the union is equal to the number of elements in the sets one by one. Let us take a concrete example. In this concrete example, let us say our set S contains A1, A2, A3, A4, B1, and B2. See, A1, A2, A3, A4, B1, and B2. Those are the elements in set S. Let us also say that set T contains C1, C2, C3, B1, and B2. You have C1, C2, C3, B1, and B2. So all these 5 elements are here, these 6 elements are here. But it turns out that B1 is here, it's also here. B2 is here, it's also here. So these are the two things they have in common. So remember that all elements in the set must be unique. So all elements in this set, they are unique. There is no repeat here. The same thing here, there is no repeat. But between this set and this set, there are things in common. But in the set itself, there is no repeat. There's no repetition inside the set. But an element can belong to more than one set. But in a set, there cannot be more than one element unique. So any repeats inside the set will be removed. So you see an example where B1 is a member of T, is also a member of S. But in S, there is no other B1 inside S. Again, inside T, there is no other B1 or B2. So everything is unique here. So if you now try to form the union, first of all, let us just even go step by step here. All elements in the set must be unique, no duplicates. In the above set, you can see that elements B1 as well as B2 are contained in set S and set T. We therefore see that a set of elements contained in both S and T is the set B1. The set of elements contained in both S and T is B1 and B2. So if you are looking for elements that belong to both, you can see that B1 is belonging to both, B2 is belonging to both. This is set now. That is their intersection. This set is their intersection, B1, B2. This set is the intersection of the sets S and T. Mathematically, we can write A1, A2, A3, A4, B1, B2 belong to S. C1, C2, C3, B1, B2 belong to T. And if you want to calculate the intersection, you look at the list here, and you look at the list of elements here, and you see that B1 and B2 are the things they have in common. So that is what constitutes the intersection. Similarly, you can also look at the union. The union is anything that belongs to either. So you have A1, A2, A3, A4, B1, B2, C1, C2, C3. You can also have another B1 and B2, but because repeats are not allowed, so you only, once you have taken B1 from S, you don't worry about the B1 again, because this new set cannot contain more than a single B1. So that is why when you count, now you see that 1, 2, 3, 4, 5, 6, 7, 8, 9 elements are in the union, whereas in each set, you have 1, 2, 3, 4, 5, 6 here, and then you have 1, 2, 3, 4, 5 here. If you add this to this, you get 11. But when you get the union, because we did not allow the repetitions to take place, so you have a situation where the union has 9 elements, but if you add the number of elements in each of the sets together, you get 11. So that is why we say that the number of elements in each one would be greater than or equal. Like in this particular case now, you have 6 plus 5, which is 11. Whereas inside there, you have only, in the union, you have only 9. But if you want to really look at the equality properly, you see that there are 6 in S, there are 5 in T, but there are 9 in the union, and there are 2 in the intersection. So you can see the equality taking place here in that concrete example. So if you look at it, so we have expressed it in English, we have expressed it mathematically. Now let us go and express it graphically. Graphically, this is what we are talking about. These are the 6 elements in S, and these are the 5 elements in T. If you join them together, this whole set of the entire boundary is the SUT, that's the union. And you can see that it has A1, A2, A3, A4, just like you have here. It has B1 and B2, just like you have here. Okay, again, here it has B1 and B2, just like you have here. And then C1, C2, C3. It's just that we do not repeat the B1 and B2. We know that in the intersection, it's not repeated because the union is also a set, and therefore it cannot repeat members. So that's it. So if you see now there are 9 elements in the union, but if you want to get the total number of elements, then you have to now take the 2 that we didn't count. So that is 2 B1 and B2. So that's why you have 9 plus 2. That's how you get the 11 here. That is the formula we're talking about here. That formula is self-evident. Anytime you forget it, just do a concrete example. You will always find it back. You don't need to memorize this thing. So it's not something for memorization. It's something to understand and be able to demonstrate to yourself anytime. Just take any 2 sets, create the intersection, create the union, and you will see that this formula always holds. Find the number of elements in one set, find the number of elements in the other set, then find the elements in the union and find the elements in the intersection. You will see that this balance will always hold. Okay, so that is the number of elements in the union and in the intersection. That is it here. So in the previous example, you see that the number of elements in the union is 9, the number of elements in the intersection is 2, the number of elements in S is 6, number of elements in T is 5. For any 2 sets, we must have this equation. Now, this equation is the same thing as this equation. All we have done from here to here is that we have transposed this expression. S intersection T is the same thing as T intersection S. Similarly, we have just done the same thing here. S intersection T union T is the same thing as T union S, and then so on. So all these equalities are coming from the fact that the union or intersection operations are commutative. They are commutative. It doesn't matter where you start, which one you put first. Like addition is commutative too. So if you say 2 plus 1 and 1 plus 2, you are going to get the same answer. So that kind of thing is commutative. But 2 minus 1 is not the same thing as 1 minus 2. So addition is commutative, but subtraction is not commutative. So you know, so the fact that some operations are commutative doesn't mean that all operations are commutative. Division is not commutative, because if you say 1 divided by 2, that's half. 2 divided by 1, that's 2. So the answers you get are different. So division is not commutative, subtraction is not commutative, multiplication is commutative, addition is commutative, union is commutative, intersection is commutative. So you must, so when an operation is commutative, it is possible to reverse the order of the operands, and you are still not going to get a different answer. That's what we are demonstrating. That's what we are saying here. So we are saying it here that T union S is stated as S union T. And if you want to be sure of this, you can do the diagram. You will see that it doesn't matter whether it's S union T or T union S. You're going to get the same. You're going to get the same answer. So the word commutative means that the operation produces the same result regardless of the relative position of the operands. It doesn't matter which one comes first. We know, for example, that additions commute, but subtractions do not commute. Unions and intersections commute. In the most general case, adding the number of elements in two sets gives us a number larger than the number of elements in their union. We are repeating what we said here. That's what we are saying here. Adding the number of elements here to the number of elements here would be greater than the number of elements in their union, because in the union, you have removed all duplicates as a result of the union. So when there are things that belong to both of them, you don't count them twice. So that's what is responsible for this. So we are saying that NS plus NT would be bigger than NS or union T. This, as we can easily observe, arises from the fact that the duplicates caused by some elements that belong to both are not doubly counted. A special case arises when the sets are disjoint. In this case, they have no elements in common. Therefore, S intersection T is 0, and the number of elements in is not 0 now, it's empty set. It's an empty set, and the number of elements in an empty set is 0. So this one is 0, this one is an empty set. So we have to say these things accurately. The intersection of S and T is the empty set. The number of elements in the intersection is 0. So this is a number, whereas this is a set. Only in this case can we then write that the number of elements in S plus the number of elements in T is equal to the number of elements in the union. Because if you add the number of elements in this intersection, you are just simply adding 0 to it, which doesn't have any effect. That only happens in the special case when the sets are disjoint. Because it's only when the sets are disjoint that the intersection is the empty set. If the sets are not disjoint, then the intersection is not empty, and the number of elements in S intersection T is not 0. So in that case, this equation will not be true. Instead, the equation that we will use in that case is this bigger equation where N of S intersection T is not 0. Okay, so let us now, we have talked about intersection, union, membership, and several other things. I want us to look at operations as a general issue. Since primary school, you have been doing abstract operations such as addition, subtraction, product, division, etc. So you've done 2 times 2, 5 times 5, 10 divided by 5. You've been playing with all those things before you got to this stage. It is important at this juncture to generalize this idea and get used to how operators behave in general. How do operators behave? What are operators? You already know about operators. For instance, the addition you have been doing is an operator. It's a symbol. And it has 2 operands, one before and one after. Now, a binary operator such as addition has 2 operands. So the things you use, like if you say 2 plus 1, the operands are 2 and 1. And the operation itself is the plus sign in between them. So a binary operator has 2 operands, one on the left and one on the right. And then the operator symbol is in the middle of them. That's number 1. Number 2, the operator also produces a result. So if you say 2 plus 1, the answer is 3. If you say 5 plus 6, the answer is 11. Every time you have an operator, there is a result. If you say 10 divided by 5, the answer is 2. The operator, the issues on operator are as follows. Number 1, there is an operand, which can be plus, minus, multiplication, division. Those are operands. Sorry, those are the operators themselves. I'm sorry. That is the operator itself. The operator is plus, minus, multiply, and division. All those are of the operators themselves. Then the operands are the things you bring together that you put on the left and the right of the operator. And then when you perform that operation, you get a result. The result is the answer after you do the operation. So 2 plus 1, the answer is 3. That is the result. In Python, there are also operators. For instance, before we get to Python, in mathematics, there are also operators. For instance, this belongs to, is an operator. It's operand. The operand on the left is this whole list. That's on the left. And the operand on the right is this single thing. So these elements are on the left, and this single one on the right. This single one on the right is a set, whereas these are just a number of elements. Similarly, you can see this is an operator. Similarly, S intersection T is an operator because S is a set, T is a set, and S is an operand, T is an operand, and the intersection operator. Similarly, the union operator, S is operand, T is another operand, and then what you have on the right in this case is the result of the operation. This is the result here, and this is the result here. Okay, so mathematically, this is what an operator looks like. In Python, we also have operators. For instance, if in your code, if you say A in Knightfoot, what you are saying here is that you might be checking whether A, an item, actually is inside the set Knightfoot. So this in here is the operator. The operator here is the in. And A is the operand on the left, and Knightfoot is the operand on the right. And now this has a result. The result is true or false. If it turns out that A is not in Knightfoot, this thing will give us a result of false. If it turns out that A is in Knightfoot, this one will give us a result of true. I hope you have practiced, that you have seen that sometimes A may be in Knightfoot, you get true. Sometimes A may not be in Knightfoot, then you get false. Now, this is an example of an operation in Python. Operands here are items A and the set Knightfoot. The operator itself is not a symbol. You see, in the mathematics, our operators are always symbols. It's either plus or minus or product or division or belongs or union or intersection. All these things in mathematics, they are represented with symbols. When we get to Python, we may have the same operations too, but they will not be represented in symbols. In this particular case now, the operator is represented in this two-letter keyword token, in. That is the operator. The operator here is in, and the operands are A and Knightfoot. So the operands here are the item A and the set Knightfoot. The operator itself is not a symbol, but a two-letter keyword token, in. The result here can be true or false. Now, you can type the following code in your Python program and then check for it's a membership program. You have a set called positive int, which is defined on these two lines, and you have another set called numerical Arab numerals, which is non-Arab, which you have here. Then you want to check if 12 in post int. For instance, you can see this is an operation. This operation is going to produce a result. Now, let us see post int. Post int is this. Is 12 there or not? Of course, 12 is there. So what will be the result of this? Think about it. What will be the result of this? Let me see whether, before I say it, let me go to, if you know it, go to the chat and type what is the result of, in this particular case now, what will be the result of 12 in post int? I want to see how many people can see that immediately. How many people can see that? Put it in Zoom.
Okay, someone has responded.
I want more people to respond. Let us see. Yeah.
Okay.
Because I want this cast to respond. Let us see how many people know what the answer is. In this particular case, is 12 in post int or not? Okay, I'm seeing more people. Aha, so more people are responding. So you can see now that if so you can now see when our program reaches this point, what will be here is not 12, it's not in, it's not post int. What is it?
You're not sharing your screen, sir.
Oh, I'm not sharing my screen, sorry.
Stop sharing.
Oh, that's terrible. Can you see the screen now?
No, sir. Okay, you are showing now.
Okay, sorry. I pressed the wrong button. So you can see the way Python is behaving. When Python sees this operation, what as far as Python is concerned, what is here is an operation, and you know operation must produce a result. The result produced here, like all of you that have answered, you know that the result produced there is true. So you can see it will print 12 is an element of +8 because it's if true. Because what is the if true? Print. Else will not be wrong because it's true. Now, if it wasn't there, it's going to do the else. So that's what will happen here. So that's the thing. So you can see how this thing works now. So this is an operation. You can see this is an operation. This operation will generate a result. That result can be true or false. For instance, if I put 50 here now, the answer will be false. So it will not do this. So you can try that in your program. Put things that are not there. You'll see that you see what would then happen. Looking at this pattern, you can check for membership of any element in the set now. Shall we? You can play with this thing now. Now that you know this is an operation, you know how an operation works now. But if you, for instance, if you say if 12 is in numeric Arab, you will see that is 4 because 12 is not there, and then so it will not execute this statement. No, this statement would have to be modified to give you the correct result. So, but at least you can see what will happen. You see, if you practice with these things, you're already programming. If you don't practice, you're already missing out and you're already cheating yourself. So that's the thing. So let us see. And from now on, when I ask a question, I will pause. I will let you respond when you can in the chat because I want some feedback from this class. Okay, so we can do this. We can now look at intersection. Because remember, when we create an intersection, and the intersection is a member. Intersection is also a set. So this is how we do it. We say these two lines are still the same as before. We can dot the way to get intersection is a numeral intersection +int. This is the way to do it. You don't need to understand this fully right now, but just write it like this. So if 12 is in the intersection, then you to print this. In fact, look here now. Let us see. Is 12 in the intersection? Because the intersection is something that's contained between the two. I want you to tell me by looking at this. Go to the chat room now again and say what is 12 in the intersection of these two sets. You can see 12 is here, but 12 is not here. So you can go to the chat room and answer. What do you think this would bring? Is it going to bring true or false? This one here. Is it going to bring true or false? Okay, I can see 2 people who have gone to the chat room. More 3. Pricing 3. More. Don't be lazy. Answer. And then if your answer is wrong, you learn something. Just look here. Only 5. We have 18 people, 16 people online. So we want more people. We don't want anybody to just be looking. So 6. There are still 10 people that have not responded. Let's have responses. 7, good. So once I get 10, I will move on. I'm waiting for 2 more people to respond. Okay. Good. So everybody is smart here. So good. So we can see this is clear. So you can see here, you can see that means that this statement will not be executed, but the else will be executed since this is coming as false. So that is the thing. That's how these things work. So you begin to see now, here we have an operation, and then here we use that operation in an if statement. We use the result of that operation in this if statement. So this if statement is dealing with the result of the operation, not the operation itself, but the result of the operation. Okay, so that's what we have here. And then we can try, so we can go ahead and then this. So we have played with some things, and now we want to just be a little bit more formal into going to programming fundamentals. Remember, you have started programming even before we get into the programming fundamentals. In programming fundamentals here, we are going to now explain into much more formal details some of the things you've been doing so that you can understand them more deeply. It's not that you have not been programming already. You have. You have been typing those codes in and you are understanding what is the meaning of an operator. You're already programming. We concretize a few elementary concepts in Python programming to get you started programming with sets and in simple concepts. Before delving into this, note two important issues. You do not have to understand everything in Python code to obtain useful results. When you do not understand some things, take note of the patterns. Sometimes the patterns in the programming code will be sufficient to get useful results. You might be able to move even when you don't fully understand by just looking at the way things are patterned. So don't just wait until you understand everything. But remember, full understanding is our goal. We expect that at the end of it, you will understand everything. So you just be understanding gradually until you understand everything. So, but refusing to move until you attain full understanding is not optimal. So don't wait, say, I don't understand everything, therefore I will do nothing. Continue practicing, and the practice itself is part of the way you will understand. So don't just find yourself stuck and not moving. So you just keep trying until you can find, because if you keep trying, you discover that your chances of understanding will greatly increase. But if you don't try, then you find out that your understanding will not be fast. You'll not be understanding things as fast as you think you should. So just continue trying, and then you'll see that understanding will come gradually. Okay, so let us see. We are going to introduce issues called identifiers, assignments, and sets. We're going to look at them in more details. You already know what sets are. You already know how to create a set in Python. We've already discussed assignment, but we are now going to discuss identifiers much more closely. Look at the four statements on the right. See, this is statement 1, this is statement 2, this is statement 3. These are 4 Python statements which will be executed one after the other normally. Now, in these statements, you can see each one of them has an equality sign. We are not saying that all statements must have equality signs, but these particular ones do. They all have equality signs. Now, this statement with their equality signs, the first thing we want to point out is that the equality sign you see in these statements do not carry the same meanings at your arithmetic equality. The equality you've been used to from your primary 1 is not the same as this one you are saying in Python. It's not the same. It is not the same. It is not the same. It is not the same. I cannot emphasize this enough. Just know that when you see an equality sign in Python, it does not carry the same meaning as the meaning that you are used to. So it is for us to know. The day you are clear about that, that means that you already moved one step in knowing how to program. They are called assignment. They are called assignments, and the statements themselves are assignment statements. Statements that are assignment statements contain 3 elements. The elements are, there is an expression that produces value or a value on the right-hand side. And then there's an identifier on the left-hand side. And then in between them, there is the arithmetic assignment. And what the arithmetic assignment is telling you to do is to compute the expression on the right-hand side. That expression to be computed must be not on the left, it must be on the right-hand side. It must be where? Right-hand side. The expression must be on the right-hand side. When that expression is computed, the result of that expression is now attached to the identifier on the left-hand side through an arithmetic assignment. So there are 3 elements: an expression of value at the right-hand side. It can also be a value at the right-hand side, an identifier on the left-hand side, and an arithmetic assignment separating them. Read it like this. Compute the expression or take the value on the right-hand side. Assign the identifier on the left-hand side as a reference to the result. That is what we mean by an arithmetic assignment. That is what is happening when you see these things that look like an equal sign. We actually use this equal sign. That's how most programming languages do. In fact, there are some programming languages, in order to emphasize it, they put a reverse arrow here instead of this sign. And such programming languages express what is happening much more correctly, but most programming languages choose to use this equal sign. But some languages use the reversed arrow, which is more accurate. But in Python, it's the equal sign that is used to denote arithmetic assignment. So there are assignment statements. So this is said to be an assignment or arithmetic assignment. So what it means here is that after these 4 statements have been executed, the set post-int will now have this element. The set num_r will now have this element. The set alpha low will have this element. The set alpha up will have this element. That is what this is doing, because the identifiers, all these ones are identifiers. We will now describe why are we calling these ones identifiers. So I think that is what we are going to do next. The arithmetic assignment here are simple because there's no expression to evaluate. Instead, in each case, we simply have a packed set with elements as we have seen previously. The statements therefore simply assigns the packed sets to on the right-hand side to the properly named identifiers on the left-hand side. So these identifiers on the left-hand side, we say they are properly named. What does it mean to properly name an identifier? Can you have improperly named identifiers? So get ready. I'm going to tell you to go to the chat room, and everybody is going to type an identifier that is improper. I will tell you how to properly name an identifier. Then you are going to go to the chat room and you are going to type for me identifiers that are improper. So once just get ready. I would first of all describe what is proper. Once such a reference is established, any use of the identifiers beyond that logical point in the program refers to the assigned result, that is the packed set. So if you now talk of post-int anywhere else, it's referring to this set containing all of these things because it has now been identified with post-int. It is this statement that makes that connection. It is this statement that makes that connection. From now on, you can use post-int and assume that it already knows what element it has. Before this point, if you use post-int, it will tell you it doesn't know what it is. But now, if you ask for post-int, it's going to show you all the elements that it contains. Now, identifier rules. The rule number 1, thou shalt not use a keyword as an identifier. So what is a keyword? Again, you will get to know what keywords are shortly. But before we go on, let me just give you an example. We have already seen some keywords. The word in here is a keyword. The word print is a keyword. The word else is a keyword. The word if is a keyword. Those are words that are only used in specific contexts. They cannot be used as identifiers. We will talk more about keywords, but the number 1 rule on identifier is that you are not allowed to use a keyword. So that means that you will need to know what are keywords, but we will get to that later on. Now, after you have avoided keyword, what else? So that means that if somebody uses post-int here, you can use a different identifier. It's up to you. It is you. You are doing the naming. It's just like if you have a child in your house, there's no ruler telling you what you must name that child. You can name the child any name you like. In fact, I remember when I was in secondary school, I had a senior in my secondary school. He had a name. His name is, there is no name. That is his name. Orukoton. That is somebody's name. So the person says there's no name, and that's a name. So you can have an identifier. You can even say there's no identifier. That's also an identifier, as long as you obey the specific rules. So you can name anything you like, provided you don't use the name of an identifier and you follow some specific rules. So let's talk more about those rules. The first character must be a member of alpha eng. What is alpha eng? What is alpha eng? Where did we define alpha eng before? Let's see. Did we define it? Let me just see that we defined alpha eng. Yes, alpha alpha eng is this. A, B, C, D all the way to Z, small case, and A, B, C, D all the way to Z, large case. So we usually use one of these to start at the beginning. So that will be what starts the name. After the first letter of the identifier, any element of alphanumeric eng can be. So alpha eng starts, but alphanumeric eng can be. So you now can use even numbers. And after the first position should not be a number, but all the other positions can be numbers. And you can use as many characters as is reasonable for you. No real limitations as long as they are, can be as long as you want. Identifiers you use are case sensitive. Because of that, post-int with I here as capital letter, with P and I as capital letter, with POS as capital letter, and with INT as capital letter. These are all seen by Python as different identifiers. Python does not know. You might think these two are the same. That is you. As far as Python is concerned, because P here is capital, whereas P here is small letter, it treats these two as two different identifiers entirely. They don't know each other. They may look alike to you, but they do not look alike at all to the Python interpreter. So remember that identifiers are case sensitive. So all these four identifiers are different. You are also not allowed to use spaces or special characters in the name of identifier. So you cannot use spaces. If you are tempted to use spaces, use underscore. If you think you must use a space, if you want to separate some of the words, then use underscore. So use underscore, it will give you the, you make it as if you have used a space, but you cannot use a space. So the underscore will be counted as a character. So you are not allowed spaces or special characters in the identifiers. Use what you'll be able to remember, as we need to recall the identifiers results or objects later. Most of the time when you are using identifiers, because you want to refer to them at another point. But it must not be a keyword. Remember, the first rule is thou shalt not use a keyword as an identifier. So now, just from the rule we have had, so I want you to all go to the chat room now, and what I want you to do right now, type illegal identifiers. Type identifiers that do not follow the rules we have said. Things that are not correct to be used as identifiers. I want to be checking. I will be looking at what you have done. I've seen one person react. Okay, yes. That is the person, that is robots. That is correct. That is not an identifier. That's not correct. But that is so yes, Oluwafemi George, that is because there's a space there. That is not the correct identifier. Who else? That's not the correct identifier. Because it starts with 6. That's not correct. That's not an identifier. Okay, go on. And then it shouldn't have a period. The identifier's name shouldn't have a period, because period has, okay, Hotmail and Mosukan, that is so it has 2 spaces. Okay, now I want you to go back again now. Okay, that is correct. There are 15 numbers. That is not an identifier because it starts with and then it has a period. So that is the reason why it's not a correct identifier. So you are following now. So now I want you to now go and don't use any of the identifiers that we have seen. Now go and write your own identifiers that nobody else but you. City room is not an identifier, we agree. Now, so go back again and now write a proper correct identifier. So we will tell you, okay, Victor, that is still not an identifier. So I'm sure you are still answering the first question. The second question now is that I want you to go back again and now type correct identifiers. Type correct identifiers now. Yes, if you baby, that's correct. That's the correct identifier. Yes, accessible, that is correct. Matrix. Eniola Lagbaby, that is wrong. That is not a correct identifier. 22, because it is 22, a number cannot start it, and you cannot have that pound sign in it. So that is wrong. Aibo Robots, BR7 is a correct identifier. So Eniola, please try again. Try again and get another identifier that is correct. Bitmap, that is, well, can be a correct identifier. Log items, okay, those are correct. Dress code, that's correct. Esther Ramola, that's correct. Bitly, that's correct. So you can see. So when we say use an identifier, so let us go back now. Now that you know what is a proper identifier or what's an improper identifier, let us now go back again and see what we are talking about. What we are saying here is that this, what you have here are properly named identifiers. This is properly named, properly named, properly named, properly named. So this is a correct arithmetic assignment. This is another arithmetic assignment because on the left-hand side of arithmetic assignment, there must be an identifier, and on the right-hand side, there must be an expression. So this is an expression that you are attaching to an identifier. For instance, if you put these things in quotes, it's also not an identifier because it's now that is now coming in as a string constant. A string constant is not an identifier. So if you put any of them in quotes, it's not an identifier. An identifier is a string or alphanumeric starting with an alphabetic character. It's not in quotes and it's not a keyword. Then it's an identifier. It doesn't have space. It doesn't have special characters. Then it's an identifier. So you phrase what identifiers are. That's good. So good. So we can move now. So we have an idea of what identifiers rules are. But you need to know more about keywords so that we will now be able to avoid using them. But even without knowing what keywords are, let me tell you something that will guarantee you will never make a mistake of using a keyword. The keywords are usually lowercase. There are exceptions. The keywords are usually lowercase. So if you follow this my rule, whereby every syllable starts with a capitalized thing, you are likely to avoid most keywords. So we usually start with a lowercase and then make sure that every time you reach a new syllable, you capitalize. That is one method that will help you to avoid keywords. So there are keywords that will still catch you, like true and false are keywords, but they start with capital letter. Okay, so in the full program you are to explore here, there are several other keywords that are of interest. And you have true, in, false, for, if, else, break, print. All these are keywords in this code. All of those are keywords. So these are codes for you to type and play with. A keyword has a predetermined meaning in the Python code. It may only be used in that context. It can only be used in the context of its predetermined meaning. The numbers in the sets are numeric constants. When numbers are just numbers like that, those are not identified, they are numeric constants. So the alphabetic letter constants are in quotes. And because if they are not in quotes, they will be taken as identifiers. So to just make sure we do not give the impression they are identifiers, we put them in quotes. Okay, so it's not that you cannot put an identifier in the list, but that identifier must have been defined to be attached to a particular constant then. But normally, if you are putting things as constants, it must be in quotes. A keyword has a predetermined meaning in the Python code. It may only be used in that context. The numbers in the sets are numeric constants. Okay, I think we have spent enough time. I want us to take a 10-minute break right now. 10 minutes break. We meet again at 5 o'clock. What's the time now? We'll meet again at 8 o'clock.
8 o'clock.
Is 8 o'clock we meet? Yes, 8 o'clock. Thank you.
Yes. So
we take a break now. Happening here. Now, for the first 4 statements, you'll understand what they are saying now. And these two, just type these two in for now. We will see here. This is an arithmetic assignment because what you have on this side is an expression, a constant called true. And this is an identifier. So what it does is that it assigns true to true false, true file. So it is, that value is not being kept. If you check in your debugger, you will see that the value it has is now, from now, this point on, is true. The important statements I want to really discuss here are these 2 statements. These 2 statements look alike. ln in postInt and ln in alphanumeric eng. First of all, postInt is a set, which we defined here. Alphanumeric eng, excuse me, alphanumeric eng is a set defined by the union of alpha eng and numeric Arab. That is how we get this set. So POS8 is a set, alphanumeric ENC is another set. Now pay attention here. Pay attention very well. This operation and this operation are completely different, even though the operations look alike. But this one is following a for, whereas this one is following an if. Let us start with the meaning of this one. The meaning of this one is that LM in alphanumeric will return true or false. So it will use that to determine whether to run this statement or to run the statement after the else. That is, so you have seen this type before. LM in POS8, whenever it's following a for, is in a different context. So let us explain what that means. What that means. What that means is that since this is a set, this is a set. It doesn't matter whether it's a set, a list, a tuple, or a dict. But in this case, it's a set. It's going to go to POS8, which is this set containing 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. It's going to pick them one by one. Each time, it will attach LM to the one it has picked. It doesn't, because it's a set, it doesn't necessarily pick them in order. It will just pick them one by one until it has picked everything. So if it picks 4, what it means is that it assigned that 4 to LM. So when it gets to this if statement, it is checking whether 4 is in this set. So LM is no longer what will be seen here, because once LM has been assigned to what was picked here, by the time you get here, what is being tested is not LM now, it is 4. If it pick 18, when it gets here, it is checking whether 18 is here. If it picks 20, when it gets here, it checks. So what this one does is that it picks LM and attaches it. It picks one, any one of the elements, it attaches it, and then it runs the code in the range with that LM. When it finishes, it comes back, it picks another one, and it has picked everything. So that is what, so you can see that even though these two statements look alike, the contexts are different. The context of one is in the front of a for loop, and the other one is in the context of a conditional loop, which is testing what it wants to decide which code to run. Here, it's going to run all the codes, it's going to run the codes following it, but it's just going to give value to LM. So let me repeat. In this particular case, it's not just going to return true or false, because it doesn't know whether there's no LM to check whether it's in POS8, because at this point, LM is not defined. So it would define, this statement defines LM to be whatever is picked among this. So that way, it picks all of them. That is what is happening here. Now, this is a very simple statement. This is an assignment. It will just assign true, false to be true. Here, it will assign it to be false. So that's the thing. And then in this statement, if true, false is, if this one is true, it will print this. If it's not, it will print the statement after the else. That's all. So you run this. Don't think you know it just by the fact that you know what we have defined. By the time you run it through a debugger and you play with it over and over and over, many of the things that we're explaining here, even some of those that are not very clear to you, will become clearer as you spend a little bit more time in working with it. So that is what, that is the meaning of some of the statements that you have here. Okay, so let me move on. Okay, so anytime you want to use a literary string in your program, the rules, okay, the rules must be observed. These following rules must be observed. Literary strings are string constants and they must be placed in quotes. If you do not, Python interpreter assumes what you have written is either a keyword or an identifier. You remember we've talked about keywords and identifiers. If you do not put your string in a quote, it will be interpreted as a keyword or identifier. It will try and see whether it's a keyword. If it doesn't see it as a keyword, then it will interpret it as an identifier. But if you want it to be a string that is not an identifier, then you put it in quotes. Then it will be a constant, literally mean what you have written. You are allowed to use either single or double quotes, any one that you like. Just be consistent. You cannot start with a single quote and close with a double quote. You must pair them correctly. Obey these rules and your code will be correctly interpreted. Okay, let's talk about looping. We've already said it before. You see, if you do for element in POSIT, it will go to the set that is here, and it will take one element, it will run this code. It will go back again, take another element, run this code. Go back again until it exhausts all the things that are here. That is how looping is done. It just goes and it just goes, runs until it runs everything. And the good thing is that when you are doing your debugging, you can actually go step by step and you see how the loop goes. And then here, whether you see when it runs this one or when it runs this one. This is a conditional statement that can only run one, either this block or this block. You can see that very clearly when you use your debugging facility. Observe that when after the colon ending the first statement, everything pertaining to the head is indented. See, you see a colon here, everything under this for loop is indented. You see a colon there, everything under the if is further indented. You see else colon here, everything. That shows that this else is not under this if. F is of the same level as the if. So it has its own colon and all the things belonging to it. So when this is returning false, it is a statement of the else, which is the one following it, that will be executed. It can be one statement, it can be several statements, it can be simple statement, it can be compound statement. We'll get to talk about that one later on. Further observe that the if else block is another block in this loop. Here is the meaning of the code. Pick elements in POSINT one by one. Each time, check if the same element belongs to alphanumeric end. If so, assign true to true false. If not, assign false. And the break keyword, using break keyword, the looping proceeds. Okay, so you go again. So this break would make it to go and pick another one. So when you do that, that's it. So let us see how it goes. I'm just trying to see. So if it is there, you see. So print POSIT is a subset of alphanumeric extent. So just try this and see how it works out. So that is for looping. Python set. So we want to just explain, because you know what a set is in your mathematics, and Python also has its own ideas of a set. The set collection that we have been using in Python is very close to the set defined in mathematics. It's not exactly the same, but it's almost the same. Each element is unique. If you add an object already in the set, it simply overwrites the previous member. The elements are not kept in any order. Simple set relations that have membership, subsets, number of elements can be found easily. Python represents its set by surrounding its listed comma-separated objects with braces. A for loop can be used to move from object to object. This is called iteration. A list that has this property is said to be iterable. A set is iterable. There are other Python collections apart from sets. Three that you will come across very soon are called lists. You've already seen lists, tuples, and dicts. We will introduce them one by one. The three, just like sets, are also iterable. So you can use, you can in your for loop now. This could be, right now, this is a set. It could be a list. And this one is a set. It also could be a list. So sets and lists are iterables. The only thing is that lists can contain duplicates, and you use brackets instead of braces for lists. It allows duplicates and multiplicities. So I'm just going to lead through some about 3 or 4 of these examples, and then we'll call it a day today. And then when we call it a day, I will wait and see whether there are questions that we need to take. Then I will discuss some of the things concerning your homework assignments and some of the things that some of you are owing us the assignment. There are people who have not done their homework in the class. So they will tell us why they are not doing their homework or what they need to do. So let us look at some interactive examples. Several examples and exercises will be given subsequently. We will ask a question If you can write a Python program to answer the question, go ahead and do so. Compare your answer to the one given. Make amends to your code if there are errors and try again. It's a good practice to attempt to write your own code first. If you are unable to do so immediately, don't be discouraged. Practice makes perfect. You can copy our code and practice it and then write your own code after. So after some time, you'll be able to write your own code first. If you fail to write a successful program, make sure you practice by typing in the solution provided and learn the proper lessons before attempting the next exercise. So exercise 1, beginning from the list of items. Ade wearing. Check if the list of what you are wearing is a subset of Ade's, or if it's in the joint set with Ade's. There is something missing here. You have to import the library that has the intersection. So I think the set is not this code is not complete. Let me see whether yes. You are going to you better go to, before you do, go to exercise 7. The first two, I think the first two things there. Maybe it doesn't need them, but I think you may need. No, it's only when you plot. Sorry, I'm giving you wrong instruction. I think this code would work like this. So beginning from the list of items Ade is wearing, check if the list you are wearing is a subset of what Ade is wearing, or if it's a disjoint set. That is the problem we want to solve. And this is a sample code. This is my own code of doing it. But if you are strong enough, you can try your hand and try and program it without looking at this code. But if you can't, look at this code and type it in and understand this, and then you can now test your own. Okay, so this is, you type this. This is Ade. You can see that this is an arithmetic assignment that assigns this set to Ade. This is another arithmetic assignment that assigns this set to Toby. And then it checks if Ade intersection with Toby is equal to Toby. Now, this double equality here is the same as the equality you know in mathematics. So when we want to do the equality of mathematics, this is checking whether this result and this thing after it has been evaluated here, it tried to do the intersection between the Ade set and the Toby set and try to check whether that result will be the same as Toby. So if it does, then we would say what Toby is wearing is a subset of Ade's. If they don't have anything in common, you say they have nothing in common. Then if there are some things common, it will say there are some things unique to both. So just check this out and use different kinds of lists and then see which one will be printed out if you have typed this correctly and understand how this code works. So recall that if A intersection B is the empty set, in which case there are no elements common, the sets are disjoint. Here, the middle one is trying to see whether the sets are disjoint, because if the sets are disjoint, the number of elements in the set, this keyword is the same thing as number of elements, because what you have inside this bracket will evaluate to the set that is the intersection between Ade and Toby. And then this one will find the number of elements there. And it will check whether the number of elements is 0. If the number of elements is 0, it already knows it's an empty set, and it will print that the two sets have nothing in common. If not, if it's not this and it's not this, then it will say there are some things common, unique to both. So that is this code here, which you can type in and play with. This is another code here. Exercise 2, beginning from the list of items Ade is wearing, find the intersection between Ade's and yours. Okay, here I've used Toby, and then and what we also want to show that the intersection is commutative. The first one, we are printing the set Ade intersection with Toby. The second one, we are printing Toby intersection with Ade. So S intersection T and T intersection S. If these two gives you exactly the same answer, then that shows that the intersection thing is commutative. So you use this your code to demonstrate commutativity of the intersection operation. Yeah. So this one, you don't need to use Toby if Toby is not your name. So you can use your name or any other identifier. Remember, even if it's your name, let us say your name is very long and it has spaces. You don't use space here. Because once you use a space, it will not be a proper identifier and you are going to get an error at that point. So Even though you are trying to use something close to your name, you must still obey the laws of Python. Otherwise, Python will not forgive you because it's your name you are typing. It doesn't know your name. It just knows identifiers. Okay. So that is what this one does. The third exercise, beginning from the list of what Ade is wearing, find the intersection between Ade's and yours. Demonstrate for any two sets, S and T, that the intersection operation is commutative. Apart from printing these results, create identifiers and assign them. So apart from printing the result, create identifiers and assign them. So, and then use the debug facility to check. Here, the difference between these two is that you just print. The print statements here are annotated. You are saying Ade union 2B is, then 2B union Ade. So you are not just, the difference between here, you just print. You don't know what you are printing. Here, it is going to type what you are printing before printing it. So that is just a slight difference. Almost the same. Number 2 and 3 are almost the same. And then exercise 4, if we write the number of elements in a set as ns, then the n of s plus n of t is equal to n of s union t plus n of s intersection t. So we are going to use this, we are using this code to test this formula. So we have Kemi here, which is maybe s. We have my own, which is t. And then we are going to do the union of the two of them. And we are assigning, when we take the length of the union, so we take the length of Kemi, we call it Kemi norm. We take the length of my own, we call it my norm. We take the length of Kemi union, we take union norm. We take the length of Kemi intersection with my own, we call it intersection norm. And then we now check. You can, by time, we now check whether Kemi norm, that is this plus this, is equal to this plus this, we check. Then if this equality sign, this now is a proper equality sign. You can see when you want the quality of arithmetic of your regular thing, you must double it. That's the only way it will recognize it. So if this formula holds, then it will say the formula is correct. If not, it will tell you the formula is wrong. And we know the formula is correct. So if it prints formula is wrong, then that means that there's something wrong with your code. It doesn't matter what sets you use, but it would be a good practice for you to not just copy our own set. You can start the first time you type it, copied. But after that, you don't have to type it, copied. Remember, when you are in your quoted strings, you don't need to follow the rules of identifier. You can have space, you can have special, you can even have some special characters, you can have dash, and all those ones can work. But because these are not identifiers. The rules we gave you before apply only to identifiers. You must use those rules when you are dealing with identifiers. But when you are not dealing with identifiers, you don't need to apply those rules. So this is code here. I don't want to go to this code. If you are strong enough, you might also check this code out. But I want to, it's 20 past 8 now. I want to pause here, and I want to know whether there are questions that have arisen from today's classes, from today's lecture. I'm stopping at page 68. Page 6. Yes, we stopping today at page 68, and we will wait for you for 10 minutes. Now, before we do that, I noticed that admin, please, how many people submitted their homework?
9 people.
How many?
9.
Okay, 9. So there are people who have not submitted their homework. If there are issues, you can, if there are things that you need to ask us now, you can go to the chat room and type it. That's something we will take note of that, and then maybe we can address it. Why are you not submitting your homework? Because once you are not submitting your homework, you are beginning to fall behind. And it's not good to fall behind, because this thing is good. This course will be easy if you don't fall behind. The course will become difficult when you start falling behind. You just see that by the time you come, next time you come, you just see that things are very hard. So better begin to do your homework. If you bring your homework, I think if you still submit it at the end of today, we'll still take it. But today is the only time we're going to give you that kind of grace. Now, if there is any question, comment, or anything, we'll wait 10 minutes and see whether you have, and we will answer you till the end of the hour if there are questions to ask. We are not going to go beyond that point today. Dr. Adewumi. Is Dr. Adewumi online?
Yes, I am.
Okay,
yes,
please.
Prof.
So you can moderate it. If there are questions that people have, then we can take them. I don't want to.
So,
the reason why I'm not going beyond is so that people who are joining late will not have too much work to cover. And we are deliberately slow and making sure that we carry everybody along. Now, if we don't carry you along, it will be your fault because we are giving you all the opportunities to ask us questions now. Ask us any question, anything about this course, whether it is the installation of your computer, installation of your software, or whatever it's not working for you, let us know and see how we can help you. Okay, over to you, Dr. Adewumi.
Okay, thank you, Prof. So the first feedback that we need from you right away in the chat room is, why didn't you submit your homework? Was there a major challenge? Please type in the chat room reasons why, so that we can actually look at it and see if there's something we can do. That's one. The second thing that I want you to comment on immediately is any question from today's class. Any question from today's class. So those are the two major feedback we need from you right now. It's very important for those that didn't submit their homework to let us know why, so that we can quickly help. The plan is that by the time we are coming in on Saturday, we are going to have an homework review that will benefit those, but it's usually better that you have done this homework, so that when we are doing that, you can actually see, oh, where did I make the errors? What were the issues? How do I do this? But if you have not practiced it, if you have not worked on it, the learning process might be difficult. So please, can we get comments? Why didn't you submit your homework? I don't want to call names because we know those that submitted. So let's get your feedback. Then if you have any question on today's class. So there's a heavy silence here. Is it that we did not submit because we just didn't want to? So I'm not getting any response. We are at least minus the 3 of us or 4 of us that are here. We are 13, and we only received 9 submissions. So I'm waiting for feedback from about 4 people here. Okay, there's a question. There's a question from today's lecture. Prof, page 54. Is the first true false equal to true necessary? Prof. Is Prof muted? Admin. Okay, let me unmute.
Okay, that statement is called an initialization, so it's necessary. It's an initialization, it's necessary.
Okay. Then the second question, I think that question says, when do we need the American pound sign as create an empty list when coding? I think that is an easy answer. Usually it's a good practice to put in comments when you are writing your code, because sometimes you might leave it off and you might not really remember what you were doing in that particular code. But when you put comments, it actually gives you a kind of reminder of what you are trying to do. So we use that hashtag, the American pound sign, if we want to make comments. When the code is running, it actually skips that comment. That's why we put and you will see that everything on that line is green, is green. So it means it's commented out. It's not really part of the code that will run. It's actually for you to know what is going on or what you are doing. For example, in this slide that Prof has put up, post int is equal to 01. If somebody else sees this, possibly if you put a comment at the beginning and say, create a set of positive integers from 0 to 20. That's a comment before the post int. So anyone that sees it will be able to know that, oh, okay, what you are trying to do is, first of all, to create a set of positive integers. You can also put another comment before the intersection to say, find the intersection between post int and num Arab. So before the line of code for intersection. So usually you use that usually called the hashtag or the American pound sign, to put in comments in your code to kind of remind you of what you are trying to do, or to guide somebody else that wants to use your code to understand what you are trying to do. So that's why you usually do that. And for those of us that have done the homework, you would have gotten your feedback. That is actually a good practice to put in comments so that you would understand what is going on. Okay, and we'll talk more. We'll talk more about that on Saturday when we are doing the homework review.
There are examples actually in example exercise 03. There are examples of the use of that sign.
For example, this exercise
03.
You see those three from 5 to 7. 5 to 7 is telling you what you are going to do next. After you write a day, you type in your a day equal to that set. After 1 to 4, now you are now giving yourself instructions on what do I want to do next. Number 1, use your name here and use the items you are wearing unless your name is Toby. So the instruction is for the next line, which is line 8. So instead of Toby equal to what you have there, or the assignment statement that you have there, you can write Tomisin is equal to, then you have your set. It could be skirts, sweaters, and all that. So 5 to 7 is actually giving a comment about what next you are supposed to do. So such comment is just to help you, it's good in case you want to go back to it after a long time. Sometimes you might not even remember what you're trying to do, but with comments, it brings it back to memory. And also, if you want to give somebody else your code to use, maybe someone does not understand what to do and the person asks you, oh, how do I do this? You can actually put in comments to guide the person on how to make use of your code.
Good. Any other comments? No chats.
Let me check. Okay, I think the two questions have been answered. For those of us, okay, when you use a keyword on a line, how do you know you are supposed to indent? Let me see. You're supposed to indent 5 spaces on the next line before typing, or when you're not supposed to. Okay, I think that is a straightforward question. For example, the keyword like the for, Prof, I don't know if you can, okay. Now you see, and I think there's an if, I'm just waiting for Prof to bring up, okay. Prof, I think I used the one on 52 that you showed. Okay, like this one now. For LM import int, then you have that colon. Once you have that colon and you press enter, Python already recognizes that the next line of code should be indented. If you look at this Python code carefully, you will notice that the lines after the line of code that has the colon, by the time you press enter, you don't even need to do the 5 spaces. Automatically, it is indented. If you look at the else also, it has a colon. If you look at the next line after that, it is indented. So if you practice this, put the colon and just press enter, you will notice that you won't need to do the 5 spaces. But I want Prof to answer the question, okay, when does this happen and when doesn't this happen? You notice that when we're doing alpha up, or when you're typing your post int, after you get to 10, look at the first line of statement, post int. After 10, comma, if you press enter after that, it doesn't automatically indent. So I just want Prof to talk more about the difference between those two.
Well, I'm not going to give any theory on this. Okay. This thing is going to come only by practice. That's the thing. So if you don't practice, you will not understand. But just know the simple rule is that when you have a colon, you are going to indent everything after that colon. If you have another colon, that is further indentation. But you have to practice what you have there, and you will continue to understand how it goes. Because
I think why does it happen that way?
Well, I say I don't have the theory. I'm not going to tell. I don't have any theory to say. You just need to know how the indentation is done. It is to group. For instance, on the first statement, now you can see that line just shows you that all the things. It just tells you all the things within the range of the for loop. Here you can see all the things within the range of the if part. You can see the things within the range of the else part. That is the reason for those indentations. It will make those things clear. But how to know what to do can only come by experience. But anytime you put a colon, you must push in by a single tap. That is the thing. So if you practice, you will see. Well, just practice with these codes. It will become second nature to you. Because that if you continue now, by the time you type this S, originally the S would have been pushed in. You have to push it back out because else and if are of the same power. But you cannot, even the one that today with me is saying will not work here, because if you are typing if and you type true false, by the time you press it, it is going to still be here. So it is you that will now have to force it to go back here. In this case. But once so sometimes you receive help from the system, but sometimes you have to know what to do. In this particular case, when you type this S, you must know that the S and the if will always be, because the else and the if are the same statement, so they must always be on this. They must always start on the same line, but their statements must be indented. So you have to practice this and then get some practice to understand how to do it. As we learn more about those statements, it will be getting clearer. Right now, we have not finished describing those statements. We are just using them to do simple things so that you can get used to them. We are still going to go into a little bit more theory of what those statements are as you continue. But like today now, we spent a little bit more time on what the arithmetic assignment is. I hope that is clearer now. And then the operations. You can see.
Okay, I wanted to actually add that I would prefer that we instead of using 5 spaces.
Yes, you use tab, not 5 spaces. Don't space, because the tab will get it right.
Yes.
It's not even 5 spaces, it's 4, I think.
It's 4, okay.
1, 2, 3, 4. You will move 4 spaces, not 5. It is on the 5th. It will now be on 1, 2, 3, 4. It will be on the 5th element, because 4 spaces that are there. 4 spaces then on the 5th space, on the 5th position.
Okay, do we have any more questions? So all the codes in the slides that we've covered today, let's type them in and run them through the debugger and get to know how they work. That's the learning process. Just like we told you, if you are just looking at it like this, you will not, that's no programming involves doing it, typing it in, running it, debugging it. Then later you can now make it your own by changing some things there. So you have to work on it. Any more questions? Okay, I'm not seeing any other question. I'm not seeing any other comments.
Okay, can we call it a day then?
Going to see if we have.
Is there any? Can we finish now? It's 40 minutes. Admin? Please ask Dr. Adewumi if we can stop.
I'm here, Prof.
Can we go now?
I just want to. I saw some people going in and out. I guess. If those people that were going in and out will close in 5 minutes. So admin. Admin, once it's 8:45, if you don't get any comments or questions or feedback, we can close the meeting at 8:45. Okay, so no other question. Admin, I think we are good to go. We can close the meeting. So see everyone on Saturday. Saturday meeting is 6 p.m. So we'll see you on Saturday.